Okay, today we're going to go over Maclaurin series, which is a way to find the value of a function using infinite series. Now, this marks the beginning of our descent into actual series calculus. In the past, all we've really done are go over infinite series equations as well as infinite series tests. But now we're going to get into the most difficult portion. And I'd say behind behind polar, this is certainly one of the most difficult calculus topics. So let's get into it. This is a Maclaurin series, and it looks incredibly complicated, but it's quite simple. It follows a very predictable formula. So right off the bat, let's say that we have a function f of x. Well, f of x is going to be equal to this right over here, this infinite series, because functions can be expressed as infinite series. And the Maclaurin series and the Taylor series are both ways to find how a function can be expressed as an infinite series. But this is it over here. The function f of x can be expressed as n equals 0. The infinite series of n equals 0 to infinity of f to the nth derivative a times x minus a to the power of n over n factorial. Meaning that, and this is the formula for Maclaurin series, meaning that each term is going to follow this order: f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared plus f triple prime a over 3 factorial times x minus a cubed, and so on until you reach the general term over here. So this will of course go on for indefinitely. You can't really evaluate the specific value of a function, but you can do a great approximation of it. And of course, the more terms you use, the more accurate your approximation is going to be. So I should mention that what a is. A is the value of what you're trying to solve a function. So more specifically, this is f of a, not really f of x. But a is the point at which you're trying to solve a function. Now, Maclaurin series is different from Taylor series because in Taylor series, a is going to have a value other than 0, whereas in Taylor series, a is going to have a value other than 0. In Maclaurin series, a is going to be equal to 0. And so I won't spend that much time going over what a is. I'll do that in my future video about Taylor series, but they're both incredibly similar. Yeah, that's essentially it for the formula. Okay, I made a small mistake in the last segment of the video. A is not actually where the point at which you're trying to find the value of a function. It's just where it's centered. There's a difference. I said I'll go over it in a future video. So I know that was a bit rushed, and it may seem a bit confusing, but I'll promise you pick up on it. So let's try to find the value of cosine 3x. Now, what's beautiful about Maclaurin series and Taylor series is that you don't necessarily need to complicate the process of solving it. For instance, we're going to try to find cosine x first, and then the way to find cosine 3x will be much simpler. So cosine x is going to be equal to 1. Sorry, x. Actually, I should probably just go over the process of doing this, because although I've gone over the infinite series representation of cosine x, I might as well do it in this video as well. So in order to find a Taylor series to the third degree, that means when x is to the power of 3, because we're not, of course, going to write out every term of this infinite series because it's infinite. We're going to have to approximate it. But in order to find a Maclaurin series, if you're making it by scratch, you're going to have to find a few derivatives of the function. In this case, we're going to have to find 3, because the third term is f triple prime a times x minus a cubed over 3 factorial. Now this over here is to the third power. However, this over here within the same term has the third derivative. So we're going to have to find the third derivative, of course, and therefore we're going to have to find the first and second as well. So the derivative of cosine x is going to be negative sine x. This is the first derivative. Now let's just call cosine x f of x. Now f double prime of x is going to be the derivative of negative sine x, which is going to be negative cosine x. Now f triple prime of x is going to be the derivative of negative cosine x, and therefore the f triple prime x is sine x. Now, as I said, we're going to have to find it centered at a, and in a Maclaurin series, the center is always 0. So we're going to have to find f of f prime of 0, f double prime of 0, f triple prime of 0, and your regular f 0 as well. So f prime of negative sine x is 0. F prime of 0 is 0. F double prime of 0 is negative 1. F triple prime of 0 is 0. If you don't know why this is, then just take a look back at your unit circle. And f of 0, that being cosine 3 times 0, is going to be equal to 1. So we've got all our derivatives in order. We might as well write out the equation now. So I'm going to say over here on the left side that, actually I'm going to have to move these. I'll just write a few numbers over here to represent the derivatives. So I can erase these and make up room. We're going to write out the equation for our Maclaurin series. We're going to begin by saying cosine x is approximately equal to f of a. We might as well write out the general term, a in this case being 0, general formula, plus f prime of a, which is of course 0, over 1 factorial times x to the power of 1. Normally we'd write x minus a to the power of 1. However, since a is 0, we might as well just leave it out. Plus f double prime of a over 2 factorial times x squared plus f triple prime of 0 over 3 factorial times x cubed. Now this will give us a good approximation of cosine x. However, x to the power of 1, f prime 0 is 0. We already found the derivatives, we already know that. And so we can take out this term because we're just multiplying it by 0 practically, as well as f triple prime of 0. That also happens to be 0, so we can take out this term as well. So I suppose we're really finding it to the second degree, but that's fine. So now we can sort of fill things in. Cosine of x is approximately equal to 1 because f of 0 is 1. We already found that. Plus f double prime of 0, which is negative 1, over 2 factorial times x squared. So this is cosine of x to the third degree, or technically to the second, because you can't really write out cosine 3x to the third degree. But this is what we have so far. This is where we're going to end it. Now, no, sorry, it's not where we're going to end it. We need to find cosine 3 of x. Now, if you'll notice, all we have to do is substitute 3x in place of x, and we essentially have cosine 3 of x. And that's why it's so simple, and that's why Taylor and Maclaurin series are so great, because you can just substitute in values. Now, if we were to, for instance, multiply this by 2, if we were to have 2 cosine 3x, then all we would do is multiply what we have so far by 2. Now, there's no reason why I did this. I just wanted to show you how versatile Maclaurin and Taylor series are. And that is it for practice problem 1. Okay, so this is our final practice problem. If you haven't understood Maclaurin series up to this point, don't worry, because there's a lot to cover. So I'll make a lot of future videos about both Taylor and Maclaurin series. But in the meantime, let's go over practice problem 2. We're told to approximate e to the power of 3 minus sine 4 from the second. Let's change that to the actually third degree. Centered at 0. So we're going to begin by finding multiple derivatives for e. of course, centered at 0. So first, let's say that e is equal to f of x. Well, we already have f of x. It's equal to e to the power of x. However, let's try to find f of 0 since it's centered at 0, and that happens to be 1. Now we're going to find the derivative of f of x, and that is, believe it or not, equal to e to the power of x as well. And of course, f prime of x, or sorry, f prime of 0 is equal to 1. And this goes on for a while. The second derivative is also e to the power of x, and when centered at 0, it's also equal to 1, as well as e triple prime of x, that when centered at 0 is equal to 1, because the derivative of e to the power of x is e to the power of x. So we already have all the derivatives for e to the power of x. Now let's try sine x. As I said earlier, I've already gone over a video telling you how to find the derivative, or sorry, the infinite series that represents sine of x, but I suppose I might as well do it again. So we're going to find, we're going to equate sine x to g of x. So g of x is equal to sine x, meaning g of 0 is equal to 0. However, g prime of x is equal to cosine x. And when g prime of 0, or when g prime of x is centered at 0, it is equal to 1. G double prime of x is equal to negative sine x. And g double prime of 0 is equal to 0. Finally, we have g triple prime of x that is equal to negative cosine x. And g triple prime of 0 is equal to negative 1. So I'm just going to write the values of the constants, or sorry, just the derivatives above for both f of x and g of x, so I don't forget later. And we're going to begin our, I should have stated that you can combine Taylor and Maclaurin series, because of course you can, they're great. So we're going to begin by finding the Taylor series, or the Maclaurin series for e of x. Now, e of x is incredibly predictable because the derivative of itself is itself. So finding the Maclaurin series is very easy. However, we're only going to do it to the third degree. So e to the power of x is approximately equal to f of 0. It should be a, however, since it's centered at 0, it's just going to be 0, plus f prime of 0 over 1 factorial times x to the power of 1, plus f double prime of 0 over 2 factorial times x squared, plus f triple prime of 0 over 3 factorial times x cubed. Okay, so all we have to do now is fill in the blanks, meaning that e to the power of x is approximately equal to f of 0, which is 1, plus f prime of 0, which is 1 over 1 times x. So we end up with x, plus f double prime of 0, which is 1 over 2 factorial times x squared. So we end up with x squared over 2 factorial, plus f triple prime of 0, which is 1 times x cubed over 3 factorial, which ends up being cubed over 3 factorial, and so on and so forth. But since we're ending it at the third degree, this is going to be it for e to the power of x. Now we have to find sine of x. Now, sine of x follows the same formula because it's a Maclaurin series. We'll just reference the one above. F of 0 in this case is going to be 0, so we'll omit the term, plus f prime of 0, which is 1 over 1 factorial times x, which of course equates to x, plus f double prime of 0, which is 0, over 2 factorial times x squared. So we end up with 0, plus f triple prime of 0, which is negative 1, times x cubed over 3 factorial. I'm referencing this formula above in case you weren't aware. And that ends up being x cubed over 3 factorial. So this is sine x to the third degree. Now all we have to find is both e to the power of 3 and sine 4. So, and then of course we have to subtract the 2. E to the power of 3 is quite simple to find. All we do is replace x with 3. And I'm not going to simplify it because it would just take too long. I'll simplify to some extent. So 1 plus 3 plus 3 squared over 2 factorial plus 3 cubed over 3 factorial. And I'll just say this is equal to 4 plus 3 squared over 2 factorial plus 3 cubed over 3 factorial. Okay. From here, we're going to find sine of 4, which is going to be much simpler than the last. And that's approximately equal to 4 minus 4 factorial. Sorry, 4 cubed over 3 factorial. Now, we have to combine the two. Or I should say we have to find the difference of the two. So e cubed minus sine 4 is approximately equal to 4 plus 3 squared over 2 factorial plus 3 cubed over 3 factorial minus 4 cubed over 3 factorial. From here, we can combine all our terms. These two cancel out here, and that's all I'm willing to simplify. So our final answer for the approximate value of e cubed minus sine 4 is 3 squared over 2 factorial. Sorry about that. I stopped screen sharing. Damn. Okay. Well, I remember what it is anyways. So we end up with e to the power 3 minus sine 4 is equal to 3 squared over 2 factorial plus 3 cubed over 3 factorial minus 4 cubed over 3 factorial. And that is the final approximate for what we have so far, or our approximate. That is the final approximate for our Taylor series. Now, of course, I'll go further in depth in future videos, and I'll explain some things that I haven't that may be confusing. If you have any suggestions, please put them in the comments below for future videos. Thank you.